Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 66. Count fertile pyramids in a land. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It's a very hard problem, and there are a lot of smart people on the Discord. So come hang out, chat about this problem, chat about other problems. Just come hang out. Anyway, so for this one, the first thing I would say is this is tricky, right? The first thing I would say is kind of break this problem down. And I'm going to do that for you by going into Paintbrush real quick. Let me set this up. Oh, okay. This is actually, not gonna lie, this is actually my second time recording this video, because the first time I forgot to put this paintbrush thing on the screen, so I like really deep in, so I wasn't able to so I'm just re-recording again. Okay, so the thing to know, okay, the first thing that I would say is to break this down to half pyramid, right? And what's a half pyramid? So a half pyramid in this case that I'm talking about is going to be something like this. So you know, for example, this is a full pyramid, like we said. We're gonna bring it to half. It's just, you know, half a pyramid. And the way that you could figure out, you know, if there's a half pyramid of size 1 is just by looking at the left and up, right? We'll look at the other half in a second, but for this half, we'll just look at the left and the up, right? Yeah, so here we can easily point out, you know, pyramids of size 1s and so forth, right? So we have 2 that I'm showing up here with an overlap of here. The key observation about this particular problem is that there's a self-similar structure, which allows us to use dynamic programming, but we'll go to dynamic programming in a second. So this one, I actually, you know, this was 13 minutes, but I actually did know the answer to this one relatively early. Or at least I knew that was dynamic programming because I've done similar problems. But I was struggling a bit with a couple of typos, which you can see in my live solve later. You could fast forward, whatever you need to do. But yeah, but the key observation is that it is self-similar, right? And what do I mean by that? That means that in order to get a pyramid of size 2, you can actually just build it by you could build it from 2 half pyramids of size 1. So I actually did this much more smoother, this video much smoother earlier, but I have to re-record it. So my apologies, because I'm trying to think about what I said earlier, because I think it came a little bit better, but now I'm a little bit silly. But yeah, but basically, okay, let's say you have why is this so fat? Okay, so yeah, okay, this is a little so yeah, so let's say you have this here. This is a half pyramid of size 1, right? And you have another pyramid of size 1 here, right? So this will actually give you a pyramid of size 2. Sorry, let me try and find a good color. This size 2 because these half pyramids of size 1, if you kind of put them next to each other in this really specific way, you can see a pyramid of size 2, right? Or a half pyramid of size 2. So that's basically the idea, and you can kind of see this going forward as well. So you can see that how you can construct 2 pyramids from 2 half pyramids of size 1 into a pyramid of size 2. Yeah. Yeah, that's the key observation, is that even though it overlaps, but it overlaps in a way such that it gives you a pyramid of size 2, or a half pyramid of size 2. Sorry, I keep saying pyramid size 2, but I mean half pyramid size 2. So one thing that we can do again is kind of see how this kind of extends in the future, right? Is that if let's say we have a pyramid of size 2 that looks like this. So now we have a pyramid size 2, and then we have another pyramid of size 2. Let's pretend this is a 1. So we have these things for an overlap of here, right? As you can see, this is a pyramid of size 2 in this corner, and this is a pyramid of size 2 in this corner, and here this means that this is a pyramid of size 3, assuming that this is a 1, this is filled in, right? So that's basically, if this cell is filled in and all the other previous is filled in, then you have, let's pretend this is a 1 and this is a 1 and this is a 1. Then now this gives you a pyramid of size 3, because a pyramid of, or half pyramid of size 3, it composes of 2 half pyramids of size 2 in the upper left quadrant, right? Okay. I'm maybe going a little bit fast, but hopefully this visualization will help in that, it lets you basically, and you could kind of show to yourself how you can construct a half pyramid of size 4 from 2 half pyramids of size 3, right? So, okay. Hope this makes sense on half pyramids. So then now, how do we get a full pyramid, right? Well, we get a full pyramid by having a similar concept. And that similar concept, and it's hard to visualize, is that, okay, let's say we have left, sorry, I don't really have my voice today, and this is why I'm like cheating a little bit with my voice. I've been talking too much. But let's say we have a left half pyramid of size 1 and a right half pyramid of size 1. It's going to look like this, but I'm using another color to denote the overlap, right? So basically, a full pyramid of size 1 is just the biggest left pyramid of size 1 and the biggest left pyramid of size 1, right? So that's basically the idea. I hope this is good visualization. It's not perfect for sure. This is not perfect, but hopefully that makes sense. So basically, so the way that I would try to visualize a little bit for you is that, okay, sorry, my speaking is a little bit bad today. But yeah, so let's say you have a pyramid of size 1 here, and a left half pyramid of size 1 here. The overlapping, I'm going to use red. This means that here we have a pyramid of size 2. I'm just going to replace this with the number 2 on the left, with the color red. And then now we have the right side of the pyramid. So let's say that we have, and you can kind of see this color already. I'm just going to do one color here for visualization. Yeah, right. So, oh no, I overdrew. So this is the right pyramid, right? And then the left pyramid, this is also the number 2, right? So then now you can see that they combine because you have a left half pyramid of size 2 and a right half pyramid of size 2. Together they allow for a pyramid of size 2. So then now the final component of this is saying that, okay, now we have a pyramid of size 2. How many pyramids is in this pyramid, right? Well, a pyramid of size 2 contains a pyramid of size 1, because now let's say you have a pyramid of size 2, which is roughly speaking, you have, say, this one, right? Okay, let's pretend they're the same color because I used the wrong color. Nope. Okay. They're not the same color, but let's say they are. Okay, let's just fill it in, right? So let's say now you have a pyramid of size 2, right? How many pyramids are there? Well, a pyramid of size 2 has a pyramid of size 1 inside, right? So that means that a pyramid of size 2 has 2 pyramids inside. And that's basically the idea behind this problem. I'm sorry that I'm saying this in a really bad way. My sore throat and speaking is really struggling today. But we'll go over the code now. And basically, hopefully with the visualization and the code, I'm going to leave. Actually, I'm going to leave this up here. And for visualization, but yeah, basically my pyramid is going to go left. So this is me just going left and up. So this is me going, okay, this is the dynamic programming thing that I have, is basically if the grid to the left, or if this is filled in, and if we look up and it's filled in, and if we look to the left and it's filled in, then we're gonna do this dynamic programming, and this is going to have the left half pyramid of size, right? So LU I sub j will give us the left half pyramid of the biggest size here. Okay, I think it's blocking some code, so let me remove this real quick. Yeah, and this is also the right half pyramid of size, right? So this is exactly the same as this, except for now we're looking at the right component instead. Yeah. So together they will combine to have one regular pyramid, and that's basically the idea here. And they have the size of and they have this size, and we count. If we have a pyramid of size 3, for example, we have 3 pyramids because we have one of size 1, you have one of size 2, and you have one of size 3. And that's basically my count here. And that returns the count. And then you may have... I'm struggling so hard, sorry friends. But yeah, so you may have a question at this point where you may go, okay, so this gets me the regular pyramid. How do I get the inverse pyramid, right? Well, the inverse pyramid is just looking at the original grid and then doing it upside down. And then, so you can say this is an upside down grid. And then, so we just call it again on the same thing, except for now it's upside down. And that saves me a lot of typing. And that's pretty much it, really. And actually, now that I see it, if you really wanted to, you could have create the 4 quadrant in a very slick way by having one function. But maybe this is slightly easier to read because this is just this is the count of regular pyramids and the count of reverse pyramids. And that's pretty much it. My talking again, I have a sore throat and it's killing me right now. I could barely keep on talking. So let me know what you think. Yeah. I mean, this is pretty terse code, I think. And it has a lot of even test stuff. So yeah, let me know what you think about this one. Let me know if you have any questions in the Discord or in the comments below. Yeah. You can watch me solve it live next, and you can see that I just had actually a lot of typos because I actually got this one relatively quickly. You wonder how I'm able to get this one quickly. I solved a similar one at some point. I don't remember where, except for instead of pyramids, I think it was diamonds or something. And I used a similar strategy, I think. So yeah. That's all I have for this one. Let me know what you think, and you can watch me solve it live during the contest next. Okay. Whew. Oh, 3 people already got it, so I'm really behind, but not a bad so far, just not fast, not slow. So, photo, baron 0, 1 and 0. This seems pretty straightforward. DP. I'm not gonna be fast about it, but well, maybe not straightforward, but it's DP. Let's see, how do I DP? Okay, so this is one. Okay. How did be? Wow, 5 people already got it. I guess I'm just slow. I mean, this is DP, but I don't quite got it. Which order do I do it though? That's the question. I see. I got it. People are very fast though. Jeez. Just double checking. Hmm. Oh, wait. 109. That's not right either. Should be 7. Right up 9. I might know how to do it, but, so that's the good thing. Bad thing is I don't know how. Okay, so this 1, 1, 1, 2, 3. Okay, that's good. Oh, this is one of size 2 at 2, 2. At 2, 1, there's a 2. Is that true? No, I think I messed up something then. Oh, I see. My corner isn't really right. My DP is a little bit off. No, it's true. Okay, now it's off by a little bit with 6 instead of 7. Because we have 1 and 2, 1. It should have 2, 1, 2, 2, but 1 and 3, 1. Okay, so this should be 2, 2, 2, 2. This is 2. Going backwards is a little bit well. No, because of this thing. So this is a 1, 1. This is a 1. No, this should still be a 2. Why is this not a 2? Oh man, typo. So many typos. Okay. Okay, so I think we're mostly good. So many people have gotten it, but I just have to do the other 2 sides. Okay. See if it times out. Okay, cool. Yeah, not a bad. Hey, yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about this problem, the explanation. How did you do? yeah, everything you like. Anyway, stay good, stay healthy, to good mental health. Have a great weekend or whatever day it is when you're actually watching. To good mental health and take care. Bye bye.